So hi, I'm Michel. I'm the good-looking guy on the left. I'm a consultant, security consultant at Enviso.
Yeah, so I'm Max. I work as a cyber analyst at Belgium's National CERT, and we're here to talk about threat hunting today and our perspective to it.
Indeed, and today we're going to talk about threat hunting, but mainly about how to start your threat hunting efforts. So we were thinking, okay, threat hunting, is that something that's only something to do for big organizations, or is that something that can be done by small to medium-sized organizations as well? So we decided to do some sort of research project and take 4 hours a week and almost no budget to see where we could get. So we want to see if it was feasible. That being said, we didn't think we needed much budget, really, to start it. Neither did we believe that in order to start it, you really need to be the biggest expert on everything in order to find some bad things in your network. So how do we tackle this?
So basically, we had a dream that one day we would be able to do threat hunting in our networks, right? Because we had a lot of questions from small to medium businesses. Hey, we hear a lot about this new threat hunting thing, but how do we start? And we don't have a lot of money, and we don't really have a lot of resources. So that was a challenge. And Michelle and myself, we sat together for a long time, and thanks to some alcohol involved and some divine intervention, we came up with 6 steps. We believe with these 6 steps, it works for us to do some threat hunting. We believe that with those 6 steps, you will be able to do threat hunting for yourself as well. First things first is you have to know your environment. It's really important, and it really amazes me that a lot of companies don't already know this. What are you trying to protect? What are your crown jewels here? Is it critical data? Is it availability? Is it something else? It's really important that you stop and think about this and identify those crown jewels in your environment, because those are the things you're trying to protect. Next to that, it's important to know that environment. And it's not always easy, and here's where the baselining come in, and we'll get back to baselining in a couple of slides. But I often compare this to a cop that's patrolling in his district. If the cop doesn't know what is normal or abnormal in his district, there's no way for the cop to know whether there's something malicious or suspicious going on, and then he needs to investigate it even further. So we get back to that in a minute with the baselining. The next step then is know your adversary. Now, this may seem or sound like an idle statement. Know your adversary. We're basically afraid of anything that's trying to get in, right? But what we did actually, we drawn a big canvas and we put 2 vectors on there. Threat actors and threat vectors. And the threat actors can be anything ranging from nation states to internal threats, your internal insider threats. And the threat vectors then can be anything ranging from social engineering to 0 days to normal malware. And when you combine these 2 things, you actually create scenarios. And those scenarios are really important to have a focus when you're doing your threat hunting. And that scenarios are not only important for the focus, but also for the time frame that you're defining in the 3rd point here. Knowing when to start and to stop with your threat hunt is as important as deciding that you want to start with that threat hunting itself, because you want that focus point in your threat hunting. It doesn't make sense to just go threat hunting sometime and don't really look at how much time you're spending with that, because you will not have a lot of value with that. Like in our case, we decided to 4 hours a week, so that's 16 hours in a month, and to get the most added value out of every scenario, we decided to rotate that monthly. So on a monthly basis, we had a new scenario we looked at and defined our threat hunt with that. Now, of course, then we do the threat hunting itself. We'll get back to that in a couple of slides. But the 5th point here is really important as well. Review your output and automate it. You really need to automate it, because if you're doing the same thing over and over again, you're basically just doing security operations, right? You're not really doing threat hunting anymore. So that's really, really important. And we'll get back to that in a minute as well.
So our approach, as Maxime already said, baselining. Baselining is something that helps us a lot, and it's something that's not really easy to do. So for that, we started small. Maxime already talked about creating scenarios, so we took a defined time frame. We gave ourselves only 4 hours a week to do this. So we really needed to focus our efforts in order to do this. Now, despite I have a network engineering background, Maxime will talk more on the network-based threat hunting.
Yeah, exactly. So before we start with that, just a step back and ensure that our mission here is completely clear to you guys. This is about how to start threat hunting. We saw a lot of people on the stage already with like, okay, how threat hunting looks at advanced with a lot of systems and networks. But this is really aimed towards the small, medium businesses that want to start with threat hunting on a budget. So just to make that clear, we decided to split it up between the network-based threat hunting and host-based threat hunting, because those are the two major parts in the threat hunting space that we see. Now, for the network-based threat hunting, you first need to start with an infrastructure, right? So you want to see what's flowing inside that network. And what we did there is basically use 2 types of network tabs. First, a network tab that will capture all the traffic that's flowing outside your network, because that's what we really want to look at. And then, of course, some network tabs inside your network that will capture all the flows that not necessarily are going outside. Now, depending on the complexity and the segregation of your network, the amount of network tabs that you will need will completely vary. But it's also important is the storage thing. Storage is pretty cheap nowadays, I would argue, and I will really urge you, if you are starting with this, to maximize your storage so that you can store as much as full data captures as possible. And if that's an issue for you in your environment, we really recommend to keep as much of the NetFlow data as possible so that we can analyze it and go back in time when we find something. Now, the tools we used, pretty simple. We're only going to use 2 types of tools. We're going to use Bro Framework, and we're going to use an elk stack, which is the Elasticsearch, Logstash, and Kibana. That's the only 2 tools that we're going to use here in the networking threat hunting. Now, before we start going into that entire threat hunting part and with Bro and the elk stack, first you need that baseline. Now, I realize this is not an easy thing. It's not as easy as saying, hey, we'll just draw a baseline from my network traffic and that's it. It's something that will evolve over time, but it's really important not to make a capital mistake that we've seen a lot of people make, is waiting until you have a perfect baseline to start with a threat hunt. That's completely wrong because of 2 things. 1, you will never have a perfect baseline. It will continue to evolve. And 2, it's better to create and maintain a baseline throughout your threat hunting over and over again. But we discovered that it's very helpful to build that baseline smartly. So that means that you're trying to filter out all the things that you're seeing in the network which are completely benign and that you checked with the business. So, for example, user agents, MIME types, well-known IP addresses and domain names. You can use some Alexa lists or other lists, references for that, just to filter out that traffic that's completely benign. And that helps a lot into creating that baseline. Very important here, and that's something we really recommend everyone that's starting with that threat hunt, make sure in the first period of your threat hunting and forming that baseline, you have that direct line to the business, because you will need to validate a lot of stuff with them in order to have that valid baseline. So that's really important. Now, Bro and elk stack, like we said before. Why I like Bro so much, it's not only in ideas, but it's the complete framework around it and the community providing a lot of scripts. And Bro is actually pretty cool. It will create logs of every PCAP you throw at it, and it will separate logs depending on the amount or the type of traffic that goes through them. So that HTTP traffic, SSL, DNS, VoIP, anything that sees it will create a different log. Now, you can just manually parse those logs with the tools of the trade, right? But you can really scale things up by forwarding those into an elk stack and then create dashboards to spot anomalies. Now, I know maybe some of you are a little bit afraid of elk because it's a lot of hassle to set it up. But nowadays, there's some really great scripts out there that can create the elk stack for you. So that's pretty awesome, and I would recommend to start with that so that you can easily set it up and don't waste too much time with the configuration itself. Like we said, we created some scenarios, and the scenario we were focused on here was the data exfiltration. Now, first example here of a manual parsing of Bro, very simple and very easy. We're just going to look at the DNS log. We tell Bro to cut it with the Brocat and only look at the queries, so Brocat is a part of the Bro framework, and we'll just cut it the field type that you want, sort it uniquely in reverse order, so we see the longest DNS queries first. Now, why the longest first? Because we see a lot of malware that still uses those long types of DNS requests, and here you already see an evil actor DNS request popping up just by going through those logs, doing the long tail analysis. That's something you can do manually, of course. Another example here is looking at suspicious user agents. Here we're going to look at HTTP log. We tell Bro to cut it only the field user agents and uniquely sort it. And those of you with sharp eyes or good glasses may have already noticed that there's a user agent in there, which is not really a user agent, and there are some other suspicious agents in there as well. Next up, ELK dashboards. We're not going to bore you with the entire setup that we did with ELK, but it's all about the search queries you define there. And they're basically sort of like the same that you do in Bro, but only you can automate them easier in a single dashboard so you can immediately spot those. For example, here we're looking at the bottom 50 user agents that were flowing through our network on a period of, in a time frame of a month. So there's a lot of interesting user agents here that we definitely would want to have a look at the first time we're doing this. So this is really the first analysis that we did, creating the baseline and looking at what is suspicious or has only occurred once inside the network. Same thing here with DNS queries, and you can see here that we immediately spotted a .top domain level list. And those of you who paid attention to some previous presentations may have noticed already that the .top domain is associated with server. Yeah, exactly, with server. So that was some malware that we found immediately with creating a dashboard like that, looking at what has communicated in the network. Now, like I said before, I really like Bro, and one of the things why I like Bro is that the community is so strong around it, and we have a lot of scripts that really can automate what you're doing with it. For example, two scripts that I really, really like. First one is the Reservoir Labs exfiltration framework. It will basically detect any file upload in a TCP connection if you run that script with Bro, which is really awesome to spot a lot of that, a lot of the file uploads that malware are using and evil actors are using for data exfiltration. Another one I really like, it's so simple but it's so effective, is the Virustotal Check. Bro has a capability of, when you throw a PCAP at it, to exfiltrate all the exe files from it, generate a hash, check against Virustotal whether they are malicious or not, and then will feed you that information. And that was really cool because there's a lot of information you get from that, and you can easily spot some of this malicious traffic. Now, what else? And this is something I also really like, is using honey tokens. Now, honey tokens is not necessarily looking for something, but it's placing a trap for a malicious actor inside your network. A honey token has no business value at all, but it is a user, it could be a user password combination, it could be a file or a folder that is very attractive to someone who's looking inside your networks. It could be accounting, it could be passwords, it could be anything else. And what you do, you make sure that it has no business purpose at all, so nobody should ever be touching that user agent, that user password combination or file or folder, and you place an alert on it. So the minute that it starts flowing inside your network or someone is using it, you immediately know that something is wrong and you need to investigate. Now, first you start looking for that low-hanging fruit, right? And you automate any detection method you find, and you try to develop new scenarios. For example, some of the scenarios we did was looking here at unknown protocols. You see the red spikes in our dashboards there, and those red spikes are the unknown protocols. So there were protocols that were not flowing in our network before, so with that baseline, and now suddenly we have a new protocol. Now, that could be that it's a valid business use, but it could also be that it is something that we should have a look at, it's malicious. Another thing here, created a dashboard looking at which domains have been contacted multiple times by a unique host. So one host, only one host, contacting the domain multiple times. And it appears that we have a Windows or Microsoft fanboy in there because he was contacting Bing and was the only one contacting Bing inside the network 80 times. So that immediately stands out, which is pretty cool to see in the dashboards. And one of the last things we did, because we only started with this entire threat hunting program ourselves to create this presentation in January, was looking at the Shannon entropy of DNS requests. Now, basically what we're doing here is looking at how random is a DNS request. It's great to spot some of that fast-fluxing command and control traffic, but also some ransomware and other malware has been using very random DNS strings. It will generate a lot of noise because of a lot of the content providers on the internet have the same methodology of generating random requests, but if you try to, if you filter those out, it's really effective. And I really want to give a shout out here to Mark Baguette's frequency.pi and frequencyserver.pi, which will allow you to generate your own entropy sets to use inside your network. Now Michel is going to talk some more about host-based threat hunting.
Yes, thank you, Maxime. So, as we already said, we're going from the standpoint from small to medium-sized enterprises. So we used what we had. So in order to extract data from the hosts in our network, we set up we already had the file server, of course. We just opened a read-only network share on which we hosted some PowerShell scripts that would then be executed by the hosts in our network on a weekly basis. And the output would then be written to a read-write network share, of course, from which we then pull the results for analysis. So a very easy setup, as you see. Now, what we're looking at, which artifacts were we looking at? To start with, the running processes, of course, is very interesting. But as you can see, there's a lot of information that you can get. So we condensed this, and we only looked at the things that we found valuable out of personal preference, actually. So here's the process name, process path, and the calculated MD5 hash. Another thing we looked at were installed services and scheduled tasks. I wasn't sure about a month ago whether I should leave in the scheduled tasks or not, because I was thinking, okay, I used it in red teaming assignments, but who else is using it? Then the Vault 7 leak came, and indeed there I saw that scheduled tasks were still used. Other known persistence mechanisms we look at are the run keys, of course, and the startup folder of Windows. So two things that are often used by the bad guys as well. And then the last thing, not really an artifact, but more looking at the logs. It's to see which users have logged on onto a system. So in our environment, small environment, each user has his own system, and normally nobody else should log on onto that system. So if somebody else logs on into that system, it's something to look into. Now the output, again, very easy. The output is just 6 files, which we could open with Excel, and we could go through manually. So within our defined time limit, that was manageable for 5 systems. But as soon as we got up to more systems, it became more difficult because there was so much data, so much running processes, so much scheduled tasks, of course. So we already talked about this. We started to build a known good baseline. So again, very easy. For each thing we knew that was good that we investigated, okay, this process, is it this good process? Is it the known process? We just created the line item. And we then created a Python script that would parse all our output and give us back this. Now, as you can see here, instead of having to go through 20 line items or 30 line items of processes or scheduled tasks or whatever, we only needed to go to 2 here, for instance. So it was took away a lot of work from us. Now, I'm going to be honest, we didn't find any bad things in the time we were doing this, which is good, of course. Then again, we're also a security company, so maybe I just haven't looked good enough, and there are bad things, but for the moment, we didn't find anything. What we did find, and what I think you will always find when doing threat hunting, is just finding irregularities in your systems. Like this example, we all upgraded our systems from Windows 8 to Windows 10. Well, our IT guy upgraded our systems from Windows 8 to Windows 10. And as you can see here, servicehost.exe on one computer had a different hash than all the other computers. So I immediately called the IT guy. I said, okay, there's something wrong because this is a Windows process. It should be the same on all our standard builds. So it turned out this was indeed the computer of our IT guy who hadn't upgraded yet to Windows 10. So okay, maybe that was a bad thing, but at least we got him to upgrade rather quickly. Now, for building that baseline, as I said, I wanted to bring down the number of line items I needed to check on a weekly basis as soon as possible. So using Excel, you could easily create a chart of which processes were most occurring. And as you can see here, Chrome is occurring over 60 times. So it's pretty easy to just check everything, all the Chrome processes. Here there were now 2 different versions of Chrome running. It's easy to check those versions and to add them to the baseline, and then next time we have, well, at least 60 line items less to check. Now, in order to keep this manageable, when you go up to 20 systems and doing this manually, and indeed starting threat hunting, it becomes difficult. So for that, we needed to focus our efforts, and that's more like Maxime said, go towards this, the scenarios. So for instance, in week 1, you can focus on like 5 VIP systems of the most important people in your organization. In week 2, you can look at all your domain controllers or on your mail servers or whatever. What you also can do is looking at frequency and do some frequency analysis. Instead of looking at the most occurring process, look at the process that's only occurring once in your entire organization. Maybe it's PowerShell, PowerPoint, no. Whatever process that is happening, and maybe it's totally legitimate, but it could also be something bad. And then as a last thing, it's something I still want to look into. It's the historical state analysis. It's taking a snapshot of a system on day 1 and taking a snapshot of a system on day 7 and see what has changed, which new items have popped up on that system, and why have they popped up. Now, of course, with the snapshot taking, we knew that we were missing a lot of things, and I created the easy timeline, rather silly timeline, but on Monday, we take a snapshot and we see everything's okay on that system. Then on Wednesday, somebody receives a phishing mail and falls for it, clicks on it. On Thursday, there's some data exfiltration, and on Friday, the malware cleans up after itself. So next Monday, we take another snapshot of the system, and everything's clean, everything's good. We haven't seen anything. So we wanted to tackle this as well. And for this, I want to use Sysmon. Sysmon, as you probably all know, is a very good tool. I'm not going to dive into the configuration I used here. A good one, a good help for me was the one from Swift on security, which is very extensive. Now, as we only had a defined time frame, and, well, because we're doing it with the thought of small to medium businesses, we really focused our efforts, or we really focused on the things we looked at. For instance, for process execution, we only looked at PowerShell execution or command line execution, or something that was like executed as a script. In terms of network connections, we would only look at the items that, or the processes that would connect to the internet that are not legitimate processes. Like there's not Windows processes that we know that should connect to the internet. There's no browsers. And as a last thing, we looked at the file creation in just some specific folders and only with some specific extensions. Now, for this, we had a use case. I had a phishing document I analyzed last month, and I thought it was a nice one. It was a Word document with an embedded link file that used PowerShell to download and execute malware. So I recreated it and used this for the case study. So in terms of process execution, as I said already, we only look at really specific things where the parent or the client process or the child process is PowerShell or command.exe. And as you can see here, something that stands out immediately is that winword.exe executes command.exe. So this is something that's abnormal, right? So if we look into more detail, we can indeed see that Word executed command.exe, but that also the command line or the command line shows that it executed PowerShell, which downloaded and executed some malware. So this was fairly easily to spot, of course. In terms of network connections, again, we only looked at really specific processes that created network connections. Like here we could see that PowerShell, again, connected outbound to the internet, which in our environment, we know PowerShell should not, we don't have any processes where PowerShell should connect outbound to the internet. We also see Word here that connects to the internet, but the IP, we looked it up, it was an IP of Microsoft to do some checking on updates or versions. I don't remember what it was. And then as a last thing was the file creation. Again, looking at files that were created in very specific folders and with very specific extensions. And as you could see here, again, PowerShell created an executable file in the appdata folder. Again, okay, maybe this could be nothing. But if we can easily trace it back using the process ID. And for those that looked carefully, also on the network connection, you could see that the PowerShell process ID was the same as that's shown here. So here again, we could easily see it. Now, of course, conveniently, this use case showed up in all three things we were looking at. From other tests, we saw that it's not always the case. So it often happens that you won't see something in the network connections or whatever, but most of the things we see will show up in one of the three, and you should be able to tie it back to the others. So this is not the end of our research, of course, so we have some other things we want to look into.
Yeah, exactly. Thanks, Michel. So basically, when we started with this threat hunting part, we wanted to look at what we could do for medium to small to medium businesses and improve their, or start their threat hunting activities. Now, some of the next steps that we're definitely going to look at in developing this even further is the historical system state comparison that Michel already talked about. Also further baselining, because that baselining will remain important to keep on improving it, and also the feedback loop to security operations, because like we said before, if you find a good methodology or a good query to find evil, hand it over to security operations, because they will be doing the automated stuff all the time, and you can be creative again and look for other evil that you haven't spotted yet with your current methodologies. And also very important is a further visualization of anomalies, because we as humans are very good at spotting visual anomalies, but are not very good at spotting anomalies in a blob of data. That's why we use our systems and our tools for. So that's really, really important. Now, we honestly believe that with the 6 steps that we showed and with some of the tools that we showed in the network-based threat hunting and the host-based threat hunting and some of the methodologies we showed today, that you can really start with that threat hunting. And that's the message we're trying to convey here and that we're trying to convey in everywhere that we come. And companies is, you don't need elite people to do this. You don't need elite software to do this. You can start already with what's available open source with some of these systems. So, that being said, it's a wrap.